So multiplying fractions is actually kind of straightforward if we look at this. I mean, it'll be easier once we can use calculators, but in the meantime, since we can't, just to look at this, this is considered abstract. So if we looked at this as an example, if we had two fractions that were being multiplied like this, then let's say this one is a over b, and this one would be c over d. As it turns out, we get to just multiply the numerators together, which means I'd have a times c. And then the two denominators being multiplied as well would give me b times d. So again, that's kind of abstract. It doesn't really help us too much conceptually, but maybe this will help. Okay, so I guess we'll look at that as an example. Some examples using this method later. We actually may be splitting those values up though as well, okay? Because all the answers that we want for this section should be simplified, okay? So not that we remember, but a week ago, right, because that was so long ago, you tend to forget. But if we can factor these numbers, then we can cancel them out. Because if we look, anything divided by itself, right? Let's say, for example, that I had 5 divided by 5. That's 1, which is great, right? I mean, that's pretty easy to do. If we set this up differently, again, I'm using a fraction, something like 3 divided by 3. Then if I use long division, I'd have 3 divided by 3. Well, how many times does 3 go into 3? Once. 1 times 3 is 3. Subtract, we got 0. So anything divided by itself is 1, which means when we find common factors for the numerator and the denominator, we can cancel those out as a 1. Now, another way to look at this may be with a more concrete example. Let's say that, I don't know, I had a fourth of a half of a sandwich. If I had a fourth of a half of a sandwich, right, and we could draw a picture on this thing to see, got some lettuce in there, maybe some bacon strips, or maybe like ketchup and lettuce. A ketchup and lettuce sandwich. Sounds delicious. Anyways, if I had half the sandwich, then I would just cut that in half, right? But if I had a fourth of that, then I've got to focus on just this portion. I'm going to focus specifically on this portion here on the left, right there. So I need a fourth of that, okay? So I'm going to split that half now into fourths, like this. Yes, they're not all the same sizes, and sometimes people hate to eat the ends. So I would actually end up cutting the other part equally, okay? So that I can see that I have, or how many pieces I have on this, right? So just looking at the half, the fourth of the half would be this portion right here, right? Well, that's one part out of how many?
4, 6, 8.
8. 8 pieces, yeah. Right there. Well, that's the same as taking 1/4 and multiplying it by 1/2. So looking there at the top, right, I did 1 times 1, which is 1. And then on the bottom, I did 4 times 2, which is 8. 1/8. Now, we may not be able to think of this all the time in sandwiches, especially when we're dividing it up kind of weird, like sevenths or something like that. But hopefully this kind of helps you understand why we're multiplying these. So 1a, what would 1/2 of 6 feet be equal to? So if you took half of 6, you'd have 3, right? So this one would be 3 feet. Translate 1/2 of 6 feet into an expression. So of is kind of a key word for multiplication. So we're going to take 1/2 and then multiply that by 6. All right, so 2a, I don't know, I like making cookie dough, right? So if my recipe, for example, calls for a half cup, but I'm dividing that in half, then how big of a cup do I need?
Fourth of a cup.
Be a fourth, okay? So this one would be a fourth of a cup. And this is why, because if we translate this, you'd have 1/2 of a cup multiplied by 1/2 of a cup. Now again, this can read as 1/2 of 1/2, which again would give us the 1/4 of a cup. Let's go over simplifying these, and we'll use kind of the same methods that we did last week, all right? But we're going to look at these a little bit different than we did with those last couple as well. All right, so on this problem 3, here's what we're going to do. Since it's multiplication of a fraction, I'm going to take this and I'm going to make it one big fraction. But remember, I'm going to need to multiply the numerators and denominators together. Okay. Now, before I do multiply these, what I'm going to want to do is find the prime factorization of these numbers. Now, we may remember from last week that 2 is already prime, and same with the 3, same with the 5, but 4 I can split up into 2 and 2. All right? So I changed that 4 into 2 times 2. Why? Because remember, anything divided by itself is 1. So if I were just to rearrange this, not that everyone does this step, but if I did 2 times 3 in the top, and I rearranged one of the 2's in front, which we can do, that's called the commutative property of multiplication. Not that anyone cares. But, see now in the front here, I've got 2 divided by 2 right there. That's a 1. Well, what's anything multiplied by 1?
1.
It'd be itself,
Yeah.
right there, right? So, as it turns out, this ends up being, we can actually just kind of just ignore that garbage right there. Well, in my numerator, now I only have a 3, and in the denominator I've got 5 times 2, which is 10. And now it's simplified completely because of that prime factorization stuff. All right, now maybe you hate that prime factorization stuff, which may happen because you understand what some of the common divisors of these are. So let's look at this differently. So I'm going to rewrite this, but again, I'm going to multiply my numerators, 5 times 9, and my denominators, 12 times 10, which would give me 5 times 9 is 45, divided by 12 times 10 is 120. Yeah, but we do need to simplify this. So maybe you know that both of these could be divided by, it looks like,
10, 5.
but 15 is not as common, right? So you look at the ends there, and these both end with 5 or 0, so they're at least divisible by 5, right? So that means I need to take both these numbers and divide by 5.
9.
Okay.
Yes.
All right, well, let's look at this. 45 divided by 5 is 9. And 120 divided by 5, it looks like that would be 24. We can do the long division. 120 divided by 5, there's 2, 10, and 24. 0 remaining. Well, 9 and 24, is there anything we can divide both of these by to simplify those? Well, sure.
3.
Yeah, both these are divisible by 3.
6.
And that would be 9 divided by 3 is 3. 24 divided by 3 is 8. 3 is prime, so if 8's not divisible by 3, which it is not, then we can't simplify this anymore. So that would be the answer right there. Now, maybe you didn't like this method either, which is okay, but you have to like a method, all right? Now, on number 5, we've got 3 fractions being multiplied. That's not going to matter, all right?
It's all the same. I think.
It's all the same. The strategy is the same. It's just the numbers may be farther apart for our numerators and denominators. So this method, though, I'm going to do this one a little bit differently. So, for example, this is cross simplification, which most people don't like, but I'm going to show it to you because it is a valid method, all right? So, for example, I've got this 3 here and that 9. I know those are divisible by 3. So, for example, I could do that. 3 divided by 3 is 1, and 9 divided by 3 is 3. So this now becomes a 1 and a 3. See how I kind of simplified that right there? All this is going to do is make the multiplication easier because we're multiplying smaller numbers instead of the bigger ones. Now the 5s will cancel each other, right? Anything divided by itself is 1. And the 2 and 10 can also simplify if I divide these both by 2. So this gives me a 1, and this gives me a 5. So if I set this up, looking at the numbers we have,
15s.
I've got 1 times 1 times 1, and then I've got 5 times 1 times 3. Now most people don't show this step, which is okay. But again, it should make the multiplication easier. 1 times 1 times 1 is 1. 5 times 1 is 5, times 3 is 15. And we simplified that. So this method kind of takes some intuition. Like you have to know what you're simplifying and what to simplify them by. But it's valid, all right, if you can do it.
That would be 10 over 1, right?
That's correct.
10.
That's correct. Yep. This is going to be 10 over 1 because anything divided by 1 is itself. So this one is going to give me a new fraction, 10 times 4 divided by 1 times 15. 10 times 4 is 40, and 1 times 15 is 15. Missed that one.
And then you want to make it.
Nope, to simplify this, we will want to change this into, just simplify the fraction. We're going to want to change this into just a simplified form of this. So, again, we got a 0 and a 5, two numbers that end in either one of those, so we know that we can divide both these by 5 at least.
9/3.
So that's close. 40 divided by 5
Oh, it's 8 then.
is 8. Very good. 15 divided by 5 is 3. So on this one, I'm going to change this 3/4 squared into 3/4 times 3/4. Now this one has parentheses instead of just two fractions multiplied by each other. That's not going to matter. We can still change this into 3 times 3 divided by 4 times 4. Okay? So we're still multiplying the numerators and the two denominators as well. So 3 times 3 is 9, and 4 times 4 is 16. 9 is divisible by 3, but 16 is not.
So it's no.
So, yeah, that's as far as we go on this one. Yeah, so this one, right, we treat that as 7 over 1. So when we rewrite this, 7 times 1 over 1 times 7, then we get 7 over 7. And anything divided by itself is 1. Done. Number 9 here, this one has a cube, or to the power of 3. So we would write this as 1/3 times 1/3 times 1/3.
1/27.
Very good, yep. So I'm going to show this extra step here though. So 1 times 1 times 1 times 3, divided by 3 times 3 times 3. 1 times 1 times 1 is 1. 3 times 3 is 9. And then multiplied by that other 3, 27. This one, I'm actually going to use the prime factorization on this one, especially since I've got 4 of these numbers are prime. The 3 and the 7s. That means that I don't need to split those up anymore, okay? So I've still got this 3. Oh, man. There we go. But I'm going to break the 6 up. Okay, I'm going to break it up into 2 and 3. That would be 6's prime factorization. So that would be times 2 times 3. And then I also have the 7 right here. Now that's my numerator. That's the top. And then in the bottom, I've got this 7 and this 7 to multiply. But the 9 I can split up. So 9 I'm going to split up into 3 and 3. So that would be 9 as prime factored. A prime factored 9. Now, again, and some of you would just start canceling out at this point, which is okay. I'm going to rearrange them so we can have numbers directly above and below each other that we can cancel out. So I'm going to rearrange this into 2 times 3 times 3 times 7. And then the bottom will be 7 times 3 times 3, and then times the other 7. So these as their prime factors show us that the 3's cancel out here, these 3's cancel out, and the 7's cancel out. Now again, when I say cancel, I mean they turn into 1s. But this is multiplication of 1, so anything multiplied by 1 is 1. And my final answer here is just what I had left, the 2/7. Now if we look at the one that we had originally, right, we could have said we can start canceling out there. These 3's cancel out, this 7 can cancel out that 7, that 3 can cancel out that 3. I can even put marks on this to show which ones cancel. And then all we're left with is the 2 and the 7. But again, it's all a matter of preference. All right, so let's try this a little differently. So I saw this, right? It seemed like everyone saw that this 7 can cancel out that 7. Okay? Now, depending on if you use the 3 with the 9 or the 6 and the 9 will depend on what you're dividing those by. It's not going to matter which one you do, though. But if I do 3 divided by 3, then I can do 9 divided by 3. Okay, so these 3's cancel out into a 1. 9 divided by 3 becomes a 3. But see that red 3, now I can take the 6 and divide that by 3 to simplify these two as well. So the 6 becomes a 2, and these 3's become a 1. Well, now what I'm left with, and I'm trying to color code this, I got 1 times 2, and that 7, if you want, became a 1. Then the bottom I had that 7, and then that 7 that canceled into a 1, and now that 9 also turned into a 1 in green right there. So multiplying these out, once again, 1 times 2 times 1 is 2, 7 times 1 times 1 is 7. Same answer, just a little different method on that. If I wanted to go back, let's say that I didn't know that with the 6's. So the 3 still turned into a 1, but now I've got a 6 right here, and that 7 turned into a 1 as well. That should be in red. Then in the bottom I got a 7, a 1, and then it would have been that red 3 right there. Now when I multiply, this would have given me 6 over 21. Both of these, though, are still divisible by 3. So that would have, again, given you 2/7. Even if you factor those out, you'd get 2 and 3, and then 7 and 3. So the 3's cancel out still.
What if you need to no canceling out?
So the reason they wanted us to find the area of this shape, specifically the triangle, right, is because the formula for finding the area of a triangle is going to be 1/2 times the base times the height. So on this one, we're just going to replace the values that we know. For example, the base, we'll say is 5 because it's kind of what it's sitting on, the base. So I'm going to replace B, the base, with that value, 5. Now, if it helps, you can change this directly into 5 over 1. Because we are going to be multiplying the fractions here, right? And then the height I can replace with 6, the height of the triangle right here. That creates a 90-degree angle. Not that we have to know that right now. But this would be 6 over 1. So we got 3 fractions multiplied together. There's a lot of 1's involved. So if we wanted to, we could multiply these directly. 1 times 5 is 5. Times 6 is 30. 2 times 1 is 2. Times 1 is 2. So this, again, is really just 30 divided by 2. Which, I mean, if we wanted to simplify it, divide both these by 2. Or you can do 30 divided by 2 directly. In any case, you'll get 15. Or 15 over 1. So the area of this triangle is 15. Yeah, they did not give us any units, so we'll just leave it as 15. So now we got a rectangle. Rectangles are a little bit more, well, I shouldn't use R. The area, A for area of this rectangle. They're just a little less complex because it's just, well, we would say length times width, I guess. You could say the base times the height still. It's really a matter of preference on that as well, but the length on this one I'm going to say is 3 miles. So I'm going to replace the length with 3. Now again, we do have a fraction, so I can make this a fraction as well. And then my width I can say is that 3/4 of a mile, so I'm going to change that into 3/4. And in solving this, now I've got 3 times 3 divided by 1 times 4, which would be 9/4. Now it's not completely important yet, but area is miles, but this would be squared. Now if you wrote this as 9/4 square miles, that's fine too. But we should label these in any case.
Always gotta label them.
Yep. This one specifically, the 2, indicates that it's 2-dimensional, which is what area is. It has length and width.
And
A legislator can override the governor's veto with a 2/3 vote. If there are 49 senators, how many must be in favor to override the vote? So this would be 2/3 of 49. And again, the word of indicates multiplication. So we need 2/3 of the 49 senators. And again, we may want to show this as a fraction so that we can multiply them directly. So this would be 2 times 49 divided by 3 times 1. 3 times 1 is pretty direct, 3. But we may need to use
90.
log multiplication for 49 times 2. And yeah, this would give us 18. And then 2 times 4 is 80 right there.
Oh. I got it.
Wait, what the heck am I doing? No, I have that 8 in the wrong place. Let me take that back. 2 times 4 is just 8.
So
That's where that
98.
goes. So, yeah, 98. Yeah, I almost got that way wrong. So this would be 98/3, which, as it turns out, is not an exact value. Since this one wants how many senators must override the vote, we should figure this out. So I am going to divide these. I've got 98 divided by 3. So 3 goes into 9 3 times. 3 times 3 is 9, so we have none remaining, but we'll drop the 8. 3 goes into 8 twice. 2 times 3 is 6. And I've got 2 remaining. So the question is, right here, I've got 32 with a remainder of 2. If I have only 32 senators vote for the veto, will that override it?
2/3. Yes.
Well, we got to look at that. So the 2 right here indicates that we have some left over, right? Which means to override it, right, we needed at least 2/3. This does not give us the full 2/3. So we need to increase this by 1. What we actually need is 33 votes
Oh, so
out of the 49. We have to kind of be a little careful on these, because 32 with the remainder of 2, the idea here is to show that you can't have a partial vote. You either vote for it or you don't. So 2/3 left means that we'd have to round that up to the next vote, because we just don't have enough with the 32 and some change.